Number 54 is a rational inequality because we have x's in the denominator. So if you look at your notes, I had two conditions that had to be met if we have a rational inequality. First of all, we need one fraction on the left, and second of all, we need a 0 on the right. So I need to subtract this 4 over 3x plus 1 over x minus 2 minus 4 greater than or equal to 0. So now I have a 0 on the right. That satisfies one of those conditions. But I also need one fraction on the left. So I'm going to make this a 4 over 1, make it a fraction, and combine these two by getting an LCD. My LCD, my least common denominator, would be x minus 2. So let me rewrite the left side with the least common denominator of x minus 2. Something over x minus 2 minus something over x minus 2. This first fraction already has the LCD, so I can leave it. But the second one needs an x minus 2, so 4x minus 2. Now if I combine these, because they have the same denominator, 3x plus 1, distribute the negative 4, negative 4x plus 8 over x minus 2 greater than or equal to 0. If I combine my like terms here, I get negative x plus 9 over x minus 2 greater than or equal to 0. So I've gotten it to where I have one fraction on the left and a 0 on the right side. Now to get our key numbers, remember we find the zeros of the numerator and the zeros of the denominator. So I set the numerator equal to 0, and when I do that I get that x equals 9. And I set the denominator equal to 0 and solve for x. And when I do that, I get x equals 2. So for a rational inequality, when there are x's in the top and bottom, you need to get your key numbers by finding the zeros of the numerator and of the denominator. Now we can do our sign analysis with the number line. So drawing my number line and putting 2 and 9 on there. Let's pick some test values. So less than 2, I could pick 0. Bigger than 2, I could pick 3. Bigger than 9, I could pick 10. But remember, you can pick whatever ones you want as long as they fall in those intervals. So if I plug in 0, and I'm going to plug it into my simplified one right here. If I plug in 0, I get 9 over negative 2. Negative 9 halves greater than or equal to 0. That's false, so I need a big old X there. From 2 to 9, if I plug in 3, I get 6 over 1, or 6 is greater than or equal to 0. That's true. So I'll check that off. And if I plug in 10, I get negative 1/8 greater than or equal to 0. That's false. So the only spot where it's true is from 2 to 9. Now, my original has a greater than or equal to, right? I'm highlighting that in green right now. It has a greater than or equal to. But remember, with rational inequalities, when you have x's in your denominator, you need to look at your domain. So looking at my original, plugging in 2 would make me divide by 0, so I actually can't include 2 as part of my answer. It needs to have a parentheses. So if there's something that's not in your domain, you need to remember to take that out of your answer by putting parentheses around it. So although the check mark is from 2 to 9, and although there's a greater than or equal to, I put a parentheses on the 2, and I keep the bracket on the 9, because 2 is not in the domain of 3x plus 1 over x minus 2. It makes us divide by 0, so we can't include it.